Hi everyone, today we're going to talk about graphing polynomial functions. This is actually really kind of cool, and I know I say that about a lot of things, but I think this is really neat because the old way of graphing is that you would plot a bunch of points and connect them and you didn't really know anything about the graph. Here we're basically learning characteristics about the graph, taking a few shortcuts, and that's going to help us to sketch the graph of these different polynomial functions, right? You guys have graphed lines before, you've graphed parabolas before, but you haven't really graphed these higher level polynomial functions, and we're going to start doing that. So what I would suggest is pausing the video, printing off the assignment sheet for today, and having that handy so as I go through the video, you can do the assignment at the same time. Excuse me, at the same time. I think that'll help sort of solidify what we're talking about as we go through this, okay? So the first thing we're going to talk about is end behavior. And what I mean by that is what's happening at the ends of your graph, because that's actually really important. Excuse me. And it's actually very interesting. I'll get to this little part of this function notation in a minute. But let's talk about the different possibilities. There's only 4 possibilities of what could happen on the ends of your graph. Okay, either the ends are going in opposite directions, which you see the 2 cases here on the left, or the ends are pointing in the same direction, which you see the 2 cases on the right. Now, on the left, you have, on the very left here, you have the left side of the function points down, the right side of the function points up. So the left is falling, it's falling to the left. Sometimes you'll hear people say, and rising to the right, or rising to the left and falling to the right. That's just terminology they use. So let me sketch you a quick graph of what that means. For example, if you had a function that did something like this. Okay, that's what we mean by falling to the left and rising to the right. That's the end behavior. That's what we're talking about. Likewise, here on the second one would be a function that looks something like this. Okay, it's rising on the left and falling to the right. So all we're talking about here is what's happening at the ends of our graph. On the right here, we have the other cases where both ends are doing the same thing. You might have both ends pointing up, so you could have something that looks kind of like a W, or you might have both ends pointing down, which might look more like an M or something like that. Okay, so these are what's happening at the ends of your graph. That's our end behavior, and that's what we mean excuse me, when we refer to end behavior. And there's a way you can tell what that end behavior is simply by looking at your function. This a sub n represents your leading coefficient. Okay, that's what a sub n is in this example. And you'll hear people refer to it as a sub n. That just means your leading coefficient. I'll do this in pink. This right here is, they don't call it a leading exponent, but it's your highest exponent. Remember that we always write our functions in standard form, meaning our highest exponent is first and then we write them in decreasing order. These 2 things dictate what happens at the ends of your graph. This is how you tell what your end behavior is. Okay, so here, excuse me, are the scenarios. On the left here, if that exponent or that n value, exponent is odd. Okay, your exponent is odd. You have opposite ends of your graph. Okay, the ends are opposite directions of each other when that exponent is odd. Okay, now how do you tell which is which? And that comes from the leading coefficient. If your leading coefficient, so a sub n, is positive, if your leading coefficient is positive, you're falling on the left and rising to the right. If your leading coefficient is negative, you're rising on the left and falling to the right. I'll show you a couple examples in a minute, but just be sure that you have this down. So write this down somewhere. Okay, when that a sub n is just the leading coefficient. If that leading coefficient is positive, as you go from left to right, your graph is rising. If that leading coefficient is negative, as you go from left to right, it's falling. For the two on the right here, okay, obviously these represented when your exponent is odd. These two are going to represent when your exponent is even. In this case, if both ends are up, your a sub n is positive. If both ends are down, your a sub n is negative, right? Up is good, down is bad. You can almost think of it that way. Those are things that you have to make sure that you know. And I know there's a lot of information there, but somehow make sure you process which is which. And I'll show you a couple examples here. If I ask you to describe the end behavior of each of these functions, I don't care about the rest of the function. This right here is the only thing I care about, because that dictates everything. So start with that first exponent. That exponent is odd. Okay, because my exponent is odd, that means my ends of my graph are pointing in opposite directions of each other. Okay, so now go to that leading coefficient. That leading coefficient is negative. Because that leading coefficient is negative, I rise on the left and I fall on the right. Okay, so this graph, the end behavior, all I have to do is show it with arrows. I don't even have to write anything. Just show with arrows what the end behavior is. If you want to write it out, you can say rising, left, falling right. That was a left there. Falling right. Or just draw the arrows. That's really all I need to see, is that you understand what's happening on the ends. Let's look at this second example. Again, I don't care about the rest of the function right now. All I care about is the very first term. Now, first thing I'm going to look at is that exponent. That exponent is even. That tells me that both ends are either up or both ends are down. Because my leading coefficient here, there's nothing written, that means that it's 1. And because 1 is positive, right, my leading coefficient is positive, both ends are up. Which means my end behavior is just this. That's all you need to do is draw the arrows. Okay, and this, if you wanted to write it in words, you could say rising, left, and right. So go ahead and pause the video for a second, and go ahead and you can go ahead and do problems 1 and 2. Okay, in problems 1 and 2, the leading coefficient, we already talked about that. The degree is that first exponent, and then just draw the arrows for the end behavior. You could also look at problems 3, 4, and 5 and try those as well. In problems 3, 4, and 5, it's talking about determining whether it's an odd or even degree and positive or negative leading exponents. So actually don't do 3, 4, and 5 yet. Let's do a quick example of problems 3, 4, and 5. So let's say I gave you this graph. Let's say I gave you this graph right here. Now, if I just gave you the graph and I said, well, tell me if it's an odd or even degree and if it's a positive or negative leading exponent. The only thing I care about is what's happening on the ends. Because I'm rising left and falling right, I have an odd degree and I have a negative leading coefficient. Okay, that's all that means. So you can figure that information out simply by looking at the graph. Likewise, if I gave you something like this, and I did this. Okay, you could look at that and say, all right, the end behavior is down on both sides, which means that my degree is even and that my leading coefficient is negative. Okay, so that takes you through problems 1 through 5 on the assignment. Go ahead and do those. I'm going to actually stop this video. I'm going to do a new video for the next part. We're actually going to take an entire function and work through it from start to finish in the next video. But go ahead and do problems 1 through 5, and then we'll get ready for the next one. Okay, I'll see you in a bit.